Good evening, everyone. Hope you're all doing well. Uh, I'm Akash Chitole, and I'll be your host for today. Today, we have with us two very special guests, Devang Parikh sir and AP Rajshekhar sir. Before continuing, I'd like to confirm if I'm audible. Can somebody please confirm if I'm audible?
You are
Yes.
audible, Akash.
Yes, thank you. Okay, so I'd like to start by introducing them to you. Yeah, Devang sir has over 20 years of experience in the IT industry. Uh, Sir has been a visionary leader and has worked with different multinational companies. Uh, Currently, Sir is the senior manager of the leading company, open source company, like we know, Red Hat company. I think most of us are aware about it. So we also have with us AP Sir. So with AP Sir has more than 16 years of experience in the IT industry. And Sir has worked on different technologies ranging from web applications to game development to app development. AP Sir works as a principal software engineer at Red Hat, which is again the same company. So we are very glad to have both of you with us today. Thank you so much for joining in. Also, I thank the audience that you all joined in. Even now, you have the time. We've already circulated the links in the group. So kindly share it with your friends and classmates so that they can join as well. All right. So as you all might know, the topic for today's discussion will be open source. We all might have a slight idea about open source. We know its importance. We can call it. It can be an internship, a kind of an internship where we gain experience working on different projects or where we contribute. So of course, we've not come together. So we've come together. Answer and Edison. So both of them will be talking and elaborating more on this. So I request all of you to be actively participative. All of you kindly put in your doubts. Any sorts of questions are most welcome. All you need to do is just put them in the chat box. Uh, I have a kind request that kindly don't unmute yourself unless you're told because we can make sure that we don't disturb the webinar. If you have any questions, you can put them in the chat box at the end. If you have to speak, sir will give you time and then you can speak. All right. So I think without any further delay, let's get started. So let's welcome AP sir and Devang sir. Over to you, sir. You can start. Thank you.
Thank you, Akash. Thank you guys for setting up this wonderful webinar. Before I start, we would like to say something. First and foremost, the slides are there just as talking points, nothing more than that. We would like to be as interactive as possible. So what idea is that after every slide, if you have questions, just post it. We can discuss about it and then move on to next slide. If there are no questions, we can just move on. So without ado, let's get started. In the words of Victor Hugo, there is nothing more powerful, not even armies, in the world that is than an idea whose time has come. So today we will be talking about such an idea called open source. The idea of open source, that how it's sustaining itself, how its contributions work, how it's working across regions, even I would say space and time in a way. That's what we are going to talk about. Why that's title of this webinar is demystifying open source. The reason is that even though open source has been there for, let's say, more than 25 to 30 years, there is still a mystery about it. Best question always that comes to me when I talk about working with Red Hat is, how does Red Hat sustain itself on projects which it gives out for free or which it contributes for free? That is one of the mysteries or mystifying effects of open source. Today we'll be looking at what open source is so that you can look at it from a practical point of view and understand what you can help open source and how open source can help you.
Yeah, so before AP, you go ahead with the slide, I would want the students and the participant to write in chat what do you mean or what do you understand by open source? So that will also help us with our explanation when we're going through the slides. Go ahead, AP. Sorry about that.
Yeah, no worries. So the agenda is this. We'll be talking a bit about what open source is, specifically its terminology and licenses, project types, the tools of the trade, because every project has certain set of tools that they say the people have to use. And last but not the least, how to contribute.
AP, you might want to share the slides because they're not showing up.
Oh, so let me do. Okay, so let me do this thing then. That's the. Is it? Got it. My screen sharing went down.
Yes, now it's visible.
Yeah.
Is it visible now?
Yes.
Yes.
Yeah, sorry for that. My screen sharing went down. So, okay. So the agenda is first we'll be looking at what open source is from terminology perspective and license and projects perspective. Then we will talk about what are the tools of the trade. What do you need at the minimal to work with any of the open source projects? And last but not the least and most important, how to contribute. So first part, what is open source? The basic definition of open source is it's a software with source code that anyone can inspect, modify, enhance. So you have a software, you have a piece of code that is free for anybody to use. Not just use, if they find any issues with it, they can go and make changes and then redistribute it so that others don't face the same issues. If it is lacking a feature, they can add that feature and then again redistribute, give to others, free of charge, free of cost, free to do whatever they want with it. In a more enterprise level definition is open source software is developed in a decentralized and collaborative way, relying on peer review, community production. Open source software is cheaper, flexible, and has more longevity than its proprietary peers because it is developed by communities rather than a single author or a company. So the main part that Red Hat stresses is the community-driven aspect of open source. A maintainer may go away from a project, but if community is there, it lives on. Best example is projects like OpenOffice. Sun Microsystem said that when Oracle bought Sun Microsystem, they said we are not going to make it open source. We are going to make it proprietary. Okay, well, the existing license of open source was that it could be forked. So community forked it, create LibreOffice, and it is thriving more than what OpenOffice was. So as long as a community is there, open source thrives. It is thriving on the contributions of the community. It is a community that leads its development, its enhancements, its how it's getting used in the world. So before moving to the next slide, queries, questions, thoughts. What is your idea of open sources?
Guys, do speak up. Don't be afraid. We are not going to kill you or we are not going to eat you. So we want to make this session more interactive. So it will be nice if you share your thoughts on chat or also like unmute your mic and share your thoughts on what open source is. Don't be afraid to ask any sort of question.
Okay, so moving to the next part. Terminology. This please keep in mind these terminologies are really, really important because like all communities, there are people who stick to certain terminologies and they don't like it being used elsewhere. The first one is free software. Free as in freedom, not as in beer. So there is an organization called FSF, Free Software Foundation, which was started by Richard Stallman. He doesn't like the term open source. He only talks about free software. In a sense, free software and open source are almost same, but there is a major difference. The major difference comes in the licensing terms which they use and the way the products are developed. Second is open source software, or more popularly called OSS. It is a collaborative, open and modifiable. So when you say open source, its basic idea is again collaborative structure. Now, why FSF and OSS are a bit different comes from how they work with the community. There are two main models that is adopted. First is cathedral model. Cathedral model is adopted by free software. The source code is available with each release, but the enhancements to the code and its release is restricted to a group of people, exclusive group of maintainers. They may accept patches, they may do whatever they want to do, but still it is under their control. That's what FSF, or Free Software Foundation, does. Then there is a bazaar model. The code is developed over the internet in the view of public, and anybody can contribute to the development. The bazaar model came into play with the initial release of Linux kernel. Till that time, everything was done via Richard Stallman's organization. If people wanted something, they had to contact that group via whichever email, or at that time there was another model called there were separate channels. Those are not present at the moment. However, what Linus Torvalds did, he created the initial release of Linux, uploaded it to FTP, and sent out to the peer groups that I have done something like this. Have a look at it. If you find it interesting, let's discuss. Tell me what can be enhanced, or if you have patches, let's work with that. And that is known as the bazaar model, because there is no hierarchy here. Yes, there are trademarks. Yes, there are main maintainers. There are levels of peer reviewers, but that hierarchy doesn't mean it is exclusively under one group. It is spread throughout the groups, throughout the peers. And that is the kind of model that actually is thriving. Next is OSI. This is another term that you will come across, open source initiative. So what happened was that initially when open source had come into play, multiple people were doing multiple stuff. Companies were doing their own things. So in the end, some of the main companies came together and said that let's create a set of standardizations around which everybody else can work with. And that's how OSI came into picture. Now, when you're contributing, these are the terms that you will come across. Committer. So committer is the person who will make the final decision whether a particular patch or a particular pull request or a particular change is accepted or not. Committer, or the group of committers are the people who would, with community, decide where the software would go next. They are not just they won't be the, I would say, one and all of the software of that particular project, but they are the stewards. They are the leaders of that particular project group. Contributor, anybody who proposes a new functionality or a bug fix via pull request. That's anybody can be a contributor. Pull request. That's how you change, how you tell the project team that you are having an idea, or you found a bug, who fixes with you. Contribution license agreement. Now each project would have its own license agreements. Some maybe there are at least 30 to 35 different license agreements in the open source world, and each have its own specialty. So whenever you contribute to a project, read through its license, understand what that license means. Now, last terminology that you have to keep in mind is open source licenses, also known as copyleft licenses. Now that term is not longer used because there is another term has come up known as permissive licenses. So we will be discussing more about it in the next slide.
Okay, so before we move ahead into the next slide, let's make this a bit interactive as well. You are free to ask questions in Hindi. आप हिंदी में भी आप क्वेश्चन पूछ सकते हो.
कोई दिक्कत नहीं है.
हाँ, जस्ट अपने आप को रिस्ट्रिक्ट मत करो, मीन्स अंदर के अंदर मत रखो. तो ये जो 2 स्लाइड्स टर्मिनोलॉजी की एपी सर ने जो शेयर की है और द स्लाइड्स दैट ही शेयर्ड, एनी क्वेश्चंस, कोई सवाल इस पे या फिर एनीथिंग, or we can play a game in terms of pulling someone's name and then asking what they understood from, say, being a contributor.
Or we can have a test after this session also.
Yeah, well, I would not say it as a test because I don't want to have this as like a college exam. It's more or less for us to see that you guys have really understood what we are sharing. We don't want to make this a very high level presentation. We want to share what we know and what we have experienced, for you to utilize what open source is and start using open source to contribute towards a good cause. It can not just be on technology or on software, but it can be anywhere. And I'll explain that later as well. But so to let's say Fahan Sheikh, I'm seeing Fahan Sheikh in my screen. What do you mean by contributor? Contributor किसको कहते हैं? Would you want to unmute your mic and share? Ozan?
Oh, yes, sir. So
Go ahead.
Yeah. So contributor is anybody who contributes to the project in any sense. So it could be either in terms of code, or it could be in terms of non-technical aspects too. So whoever's joining in together for the main aim of the main goal of the project, he's a contributor.
That is correct. I like that. Good. So so I guess the fundamentals are there. Now, in terms of the models like free software, open source, Cathedral, and others, are we clear on that aspect as well? Means AP, would you want to ask anyone if we're clear, or just we want to move ahead?
So, just one question. What you understood between Cathedral and Bazaar? When I say Cathedral model and when I say Bazaar model, anybody, what is your understanding? Without looking at the slide, you can't see because I've changed it. But what have you understood?
Yeah, means anyone just go ahead, or I'll just pick someone's name.
So in the Bazaar model, everything is open for the people to contribute to, whereas in the Cathedral model, the inside codes are not visible to the people and they are restricted.
Yeah, I would add one more line. When you say Cathedral model, how the vision is taken to the next level is not completely transparent. They may code they may share the code with you, but they won't make transparent how they are going to, what their vision is in the end. That is one of the major another difference. Thanks. So let's go to the next one. We talked a bit about license and the terminology. So what are the different kinds of licenses? How they impact the kind of project you're working on? Licenses that comply with open source definition, that is, they allow software to be freely used, modified, or shared. As I said, there are nearly 50 licenses within the open source space. So each license provide a particular aspect the way you want to use it. Now there are two main categories of licenses that is available. First is copyleft and second is permissive. Copyleft, in that case, users must use the same license as the original software. Cannot release the existing product under more restrictive license. Example is DPA. Best example I can give you. Let's say you created a tool. You gave it out freely to everybody, but you said that if you are using this tool, if you are making any change to this tool and you are going to give it out freely to somebody else again, you should use the same license and you cannot change its license. That means you cannot make some parts of it only usable as a with money and other part is free. That kind of changes to the license is not possible when copyleft licenses are used. The best example of copyleft license are GPL family, that is GPL V1, V2, V3. Then comes the permissive, allows you to copy, modify, recombine, and redistribute the work with minimal restriction. Usually, only attribution is required. For example, this comes on that's the main reason most of the libraries that you work with, whether it is Python, Java, Node, JavaScript, any library, they come with this kind of permission license. That is a permissive license. The reason is that when you create a library, you can't tell others that you cannot modify and use part of it as proprietary. There may be instances where the modification being done to the particular library would be such a way that it cannot be given to the public in general. And so in those cases, if you think your product, your project is going to have that kind of model in the future, always go with the permissive licenses. Otherwise, there could be serious actions. It had happened in the past and it could happen in the future. So if you want to know more, this is the place to know about it, open source org/licenses. It details all licenses available at the moment. So before going to projects, any questions about copyleft and permissive?
This is a very quiet group.
Either you are understanding what I am saying or you are not understanding it completely. I hope it is the first one.
I guess it will be. Let's move ahead, AP.
Yeah. So what are the type of projects that come under open source umbrella? Products like Mozilla Firefox, LibreOffice. Frameworks libraries. So most of the frameworks that you use today, Spring Boot, Flask, Node, or any of the NPM libraries, those are all comes under open source. Tools, pip, Maven, NPM, Gradle, Make, all these things. Last, very important part of the type of project is called concept implementation. So the issue with proprietary softwares are that unless it can go into market and get support or get profit, they are not even created. They are left out in the space of proof of concept. But that is not the case with open source. If you have an idea, if you have a concept which you want to test out, you can use it. At an enterprise level, example is Openstack. Nearly in 2000, 2005, in that time, there was no way where the cloud-based systems were able to communicate with each other. There was no base foundation for that. There was no collaborative approach. That's how OpenStack came into picture. On the other end, we have something called GameDora. Idea is studio as a service. Devang sir will explain more of it. It's again an idea. We are testing the waters. If it was, let's say, if it was part of a proprietary system, it would have been very difficult to test out waters in this way. But since open source is there, we can really test it out without the fear of failure.
Yeah, so I guess to add to what AP also said, it's not just the software piece that is open source. There are multiple other industries that are open sourced as well. So giving an example, hardware is also open source, like your motherboard and other piece. Now, a simple piece that I can explain right now in terms of why open source is important and how it really affects is talking about the current situation, the COVID pandemic that we are in. And everyone knows about it, that it's not a good situation outside. Vaccination is important. But how are vaccines made? Normally, researchers and companies, they do a lot of research, they create these vaccines, but they patent it. When you patent it, you have the right to sell it. That is where it is closed source. Now, what it means that, say, AstraZeneca or Pfizer and Moderna, you all have heard of these names. These are companies who have made these vaccines and have patented it, and they are using this patent. And if countries like India or others want to co-create these vaccines, they will have to buy those patents and then co-create it. Now think about it. If the vaccines were open sourced, it would have been easily massively available to all the countries in the world, where they can use the open source patents, not the patents, but the open source technology. They can understand how the vaccine is made and then create it in their own country and then easily distribute it. So it's not just software, but it is also concept, and it is also life changing pieces that can be open source. So that is why open source is important, and that is why contribution is important. And again, we will share more about GameDora in the coming slides on what the concept is all about and how it evolves and things like that. But I wanted to share that the types of projects is, don't just think of open source as in your IT or the software industry, but how things can also change in other industries or other places as well. Go ahead, Open.
So, so when Devang sir said about the vaccines, something came to my mind. A story came to my mind. Do you know? Even before the term open source was there, there was one person who did exactly the same thing that open source does now with medicine. It's insulin. The person who discovered insulin patented it and then released the patent to everybody to use. That's the main reason insulin is available at low cost. If at that moment, like it was somewhere around 60 years before, if the inventor of the or discoverer of the patent of insulin hadn't done that, people with diabetics would have really hard time. So the concept of open source was there in one way or another, and is still going on. It's kind of percolating into every strata. So we talked about what open source is. Now let's talk about what are the tools of the trade. So thing is that any project that you work with would be in a particular language, in a particular framework, would be using set of libraries. So for that to work perfectly, there are certain tools, there are certain practices that come into play so that the project can go as planned. First is called source code management, or SCM. You have, let us say, as I said, open source is bazaar model. There are hundreds of contributors. How would you know which contributor did what changes were there, and what effects are those changes having on the source code? That's where the source code management systems come into play. They track the modification. They help to resolve conflict. So let us say two people, Arzu and Arya, you both contributed a particular project, but the changes were on the same file. There is a conflict. If there was no source code management, you wouldn't even know that there was a conflict. One would override the other one. So it helps you to track the changes, plus find out where conflicts are and resolve it. So the popular SCMs are CVS. CVS is, I would say, the grand old daddy of all the source code management systems. It works on a client server repository model. That means there is a server to which you push your changes, and everybody else is a client. SVN. SVN is again a client server repository model, but with enhanced versioning. So issue with CVS was that there was no concept of versions. You did a release today, but how would you say that the changes that you did up to this moment was version 1 and the changes from now on is version 2? CVS didn't have that idea. That's where SVN came into play. It provided that particular idea of enhanced versioning. It's still being used specifically with Apache software. The latest and the greatest kid on the block is Git. You can provide it Git, you can provide it JIT, it doesn't matter. It is a distributed repository model. There are no servers. GitHub is a remote repository. You pull it from there. You have your own repository. You are a server. Tomorrow I can connect to your Git repo and pull from it. It doesn't say that there has to be one server. That's the main reason why it is called distributed repository model. And all the open source softwares are not transitioning to Git because of the way it looks at software. Open source is bazaar model. That means having a centralized system which controls everything wouldn't work well. However, Git is a decentralized system where every person who is having that Git repository could potentially become the server for another person. So those are the source code management tools. Queries, questions before moving to next slide?
So could you please explain Git again?
Okay. So so think about this. Let's start with server client server model. You have a server where the source code is there from where you pull, and you make your changes, and then you push the code modifications back to that server. Now think of every person who is having that particular code being a potential server. So Aishi, let's say I am doing the same project that you are doing. However, I want to work on the things that you have already done and enhance it. But you have not yet given it to some other place. So what I will do is that I will contact you, ask for the link of your Git repo, and use that to get your source for me. Tomorrow, somebody else can do the same from me. Getting an idea?
Yeah, AP, I
Yes,
guess if
sir.
you can give, okay, or I guess if you can give a layman's example, like in layman terms, a client server, think of it as you going to a restaurant, you are the client, and the person that is serving you with the menu or the food is the server. So that is where a client server model comes. Now you would ask something, and the server would serve you with the request that you are working on. And I guess Git would be kind of like a buffet menu where you go into the restaurant, you have all that is in front of you, and it's all you pick and go and choose the repository that or the food that you want to eat, and then that's how it works on, and something like that.
Another example is you have heard of torrents.
I don't think anyone has not heard of torrents.
So torrent is another example of what Git is. You download a particular software, particular book on your system. Somebody else wants it. For them, your system will act as a server. You need something else from somebody else. For you, that person would act as a server. So that's how Git also works. You have a piece of code, you have a modifications that is required by somebody else, so they can contact you directly without going through a centralized system. They will directly connect to your system, get the code, make changes, push it back to you, so that you will know what changes were there. Then you can do the same with other people.
Okay, so here, let me, you have a question, Ayushi?
No, thank you.
Okay, so let me, again, now this is again a quiz time. So who would want to say what is basic difference between a client server and a Git repo distributed repo model? What are what is the one major difference that you see, and why is distributed far better than client server? Don't make me pick a name. I guess I will.
It seems this is more of a class than a webinar. That's
Yeah. No worries.
the
So Shantanu, I see Shantanu Patil in front of me. Would you want to share or answer the question that I asked? You can unmute yourself. Nope. Okay. How about Gaurav? You want to share what is the major, why is distributed piece far better than a client server? Akash, Arzu, anyone? Arya?
So I guess for distributed, it is better as instead of pinging on the same server, everyone can have the code from the previous person.
Yes, but let me put it in a very simple manner. So with distributed, you don't have to ping one resource. So the resource, for example, whenever your university puts an online result, or say 10th or 12th is putting their results live on the school or the government website, what do we find? We find that whenever we go in, want to check for a result, we get error 404 not found, 503 server is so busy. Why? Because everyone is just pinging to one resource. So rather than that, if it was distributed, for example, if that same um, mark sheet was uploaded to multiple different servers and multiple different locations, when you ping for that server or for the mark sheet, it will go to your nearest location and get you it. So that means that it doesn't have to go to just one server, but it can ping to all the different servers and then get it faster. That is why the distributed is far better than the client server model. Was that clear?
So basically, we can say that there is less traffic in the distributed model.
Traffic would be more sparse.
Distributed, yes.
Yeah.
So it again, yeah, the other example is that you have to go to your university. You only have one road to go there, and that road is full of traffic. That is a client server model. So the traffic is heavy over there. But with distributed, if you have multiple different routes, then you can distribute yourself, or the traffic can be distributed to get to one single. Well, that's not a great example, but that means it because it's not getting to one server, but you're getting to multiple locations, and you're kind of getting your end result at multiple locations. But it is distributed, so traffic can be managed, but it is faster and easier to find things from different places, since you're getting that same thing from different servers.
So another example is you want to purchase a book. Let's say that book is available only in one shop. What would happen? The shop says that book is all sold out. That is the client server model. But if that particular book is available in multiple stores at multiple locations, even when one place is going out of the books, there will be other places from where you can buy it. And that's the main reason open source is called bazaar, because that's how bazaar works. It's so if you go to any market, you want to buy anything, there won't be just one place where you can find it. There will be multiple places to find it. So getting an idea now?
Yep, I think we've got a lot of examples. We can move ahead, AP.
Second part is issue tracker. So let's say this thing. You are working on a project. You found some bug, or you found something that could be some enhancements that could be done. Where would you put it so that everybody else can see that? So that there can be discussion, so that it can be confirmed whether that particular enhancement is required, that bug is actually a bug and not a feature. That is where issue trackers come into picture. What it does is that it provides you a way to manage how your issue goes from being found to actually being resolved. The whole life cycle between these two steps. Generally, there are the issue track. Most of the common issue trackers provide you a way to manage how you mark these steps or the life cycles, but there are certain which doesn't. So keep that in mind. Now, the popular issue trackers are with GitHub and GitLab. You have issues. So if you go to any project, there will be a tab called issues. What it essentially says is that I have found this particular bug, or I need this particular enhancement. Can that be done? Can we have a discussion on that? Sometimes these issues would be just conceptual. They won't be even part of the actual application. It would be like something, can this particular concept be implemented as a part of your application? If yes, what are the hurdles? If yes, if no, why? Then you have Bugzilla. This is the most commonly used non-GitHub issue tracker, and this is the most, I would say, oldest. Bugzilla was where even Linux kernel started their bug tracking. Last but not the least is Jira. It is not open source. It is proprietary. They don't give you the source code, but you can use their instances. You can use their systems with a particular open source subscription. Issue trackers are not that complex. The only thing you have to keep in mind, each issue tracker provides a different way of managing the stuff. It means different sets of life cycle. For example, let's take Jira. Most of the time, Jira has things like new. That means you have just created it, accepted that it has been considered as a bug. In progress, development is being done. QA, that means development is complete and testing is being done. Released, that means issue has been fixed and you can now start using the software. Whereas Bugzilla may tell something like new, verifying, post, released. So whenever you go for a project, please keep in mind what kind of issue tracker they use. Sometimes, even if it is a GitHub project, they may have a different issue tracker to track things, because for their release processes, that may be a easier way. So whenever, first thing you have to look at is what kind of SCM they are using. Second is what is the issue tracker they are using. Because only through issue tracker, you can actually get to understand whether whatever you are going to raise is already raised or not. Now coming to build tools. This is where most of the time contributions kind of get stuck initially. Because each project, based on the language, would have a set of build tools that you would need to have on your system. So what kind of build tools are there? If you're working on a C++ project, you have something called make and CMake. So essentially let's take example of C. How do you build a C file? Anybody? What do you use? Let's say I give you a C file. How do you compile it and how you run it, or how you give it to another person? Yes, GCC compiler. Now let's say you have 2 header files and 2 source files in such a way that header file 1 has to be compiled first and then header file 2. That means if you are directly using GCC, you will have to write that manually. First GCC first set, then GCC second set. This is where build tool come into picture, like make and CMake. What you can say is that these are the set of files that I want to compile. On this, the dependencies in this format. And then give that file, give that build that's not make file to a tool called make or CMake. It will internally invoke GCC, and according to the rules that you have specified, the steps that you have specified, it would build them. So this makes things very easy for systems, for the projects which have, let's say, 100 or even thousands of files. And this becomes more and more important when you are working on projects where there are multiple contributors. You need to have a standardized way of telling people how to compile the source code, run it on their system, test it out, and then create a pull request. Because otherwise, what would happen if people are not able to test it locally, compile it locally? They will create a change, ask the committer to test it out, and committer would be like, I don't have time. So that's where build tools come into picture. For C, you have make and CMake. For Java, you have Ant, Maven, and Gradle. Of this, Maven and Gradle are the most popular. For Python, since Python is interpreted, you don't have build tools, compile tools, but you have setup tools. So for example, you have a project with, let's say 6 files, and you want to tell other person to use it. You don't, essentially, before setup tools or pip came into play, what people used to do was they would give the archive or zip file of that particular source, ask them to extract it and run a particular file. But with setup tools, what essentially happens is that there will be a file called setup.py. You will just run python -f install or build whatever you want to do and give setup.py. It will do essentially everything. It will download all the libraries that it needs to download. It will set up the environments it needs to set up. It can do everything. So essentially, you make the life of the contributor easier. It makes the life of the maintainer easier. For JavaScript, Gulp, Grunt, Webpack, these may not be, if you have not worked on, let us say, Angular or React, these terms you may not have come across these terms. But if you have, great. So I would just like to know how many of you have heard of Gulp, Grunt, Webpack, React, Vue CLI. Anybody? So React, systems like React or Vue, what they do is that they take these build tools and create their own way of processing their application, creating the, I should say, making it work on your system so that you can test it out. So that's how it is. You will be coming into contact more and more once you start looking at different projects. So any queries, questions for build tools?
Nope, I guess we can continue.
So before moving, I would like to give a anecdote about pip. So we had this project where we had to deploy a Python project onto the server. Before pip came, what we had to do was that we had to actually copy the complete code onto the server, either via git pull or whatever it is, and then essentially set it up on the server itself. But with pip, what we started doing was that it was in a git project. Pip give the git project's URL to the pip, and it will automatically install everything without even copying the code. So that's the part. That's the beauty of build and distribution tools. So coming to the most important part, how to contribute.
So I guess before we move ahead on how to contribute, has anyone over here contributed to any open source project?
Or thinking of contributing to any open source project?
Thinking, yes.
Awesome.
Great. So Rome was not built in a day. Always remember that. Everything was done step by step. No contribution is too small. What I have seen most of the time is that when people start contributing, they think that contribution only means code contribution. No. Rather than code, sometimes things like documentation, enhancing the documentation, or helping with issue tracking, or doing the beta alpha testing. These things are becomes much more important, because code can be written by the maintainer themselves if they want. However, they may find it either may not have the complete bandwidth to test it out, or may not have the resources to test it out, or may not have the idea how to test edge case, things like edge cases where this particular thing is having issue only when these particular steps are done. Best example I can give you of Mozilla. If you go to Mozilla, the way they provide the issues for you to contribute starts with translations and go up to creating core modules. And that's how Mozilla has evolved so much, because people didn't stop and think, oh, even if I translate it to my mother tongue, what good it will do? They translated it, so Firefox is almost everywhere now, in whatever language they want. So types of contributions. I will be using GameDora and Firefox as examples because Firefox is a product, whereas GameDora is a concept. They are two ends of the spectrum. Type of contributions. First is documentation. README, wiki, architectural diagrams. Let's say you want to contribute to GameDora, which is a concept. You might have architectural thoughts, what should be done. You can provide it as a architectural diagram. Let's say you want to contribute to Mozilla, Firefox. They are enhancing every day, so their help menus may change, their wikis may change. You might go help and do that. Testing and raising issues. So when you say testing, it's not just code testing. It is functionality, security, testing on different environments. Let's say I only have Linux system. Maybe you have Windows. You can test it out how it works on Windows. What are the issues with Windows? Raise those issues. Second part with testing is that any system, anything, like for example, again I said GameDora is a concept. We have released alpha version. Unless somebody tests this out, we won't know whether that concept is actually viable. That's where open source contribution in form of testing, any kind of testing, comes into play. Raising issues on issue tracker with details and reproducers. This is I would say the most important of everything. If you find an issue, you raise the issue with details and steps to reproduce. So what will happen is that when the maintainer or anybody else, any other contributor wants to pick up that issue, they can easily check it and reach back to you and say that these are things I have found. Is this what you're observing? Or this is how we can fix it. So raising an issue after testing is the most important of all the contributions, I would say. Most of the open source softwares fail is at this point. If the community is not testing the software and raising the issues correctly, they can't go ahead, because they don't know what is they are lacking or at what place things have to be improved. That is called issue triage. So you have a set of issues coming to you. So you start looking at which is the most important, which is the most critical, which should go first, which should be tackled first. For a project of the size Firefox, there are at least 10 to 15 triagers, just triagers. Their job is, they are actually volunteers. What they do is that they keep on looking at the issues that are coming up, look at how impact it is having on the user experience, assign, mark it as critical or trivial, means very less impact, or needs it, whether it is a feature enhancement request, that kind of thing. Then comes the code patches and PRs. Even though this contributes, people think that this contributes most to the open source, but on an average, it's just 20-25% of the total contribution, because community thrives on wikis, architectural diagrams, testing, issue tracking, issue triaging. So everything that you do, even just fixing a typo in a README would help some people. many people, because that typo may create how they are looking, how they are reading it, trying to implement it on their system. So how would you contribute? Before going to this path, I would say, when you think of contribution, don't just think of things like Google Summer of Code or those kind of events, because they sometimes, these events doesn't fully embrace the spirit of open source. There may be projects which they tout as open source, but once you do the contribution, they may change the license. So be very careful when you are applying for any of the projects in things like GSOC or that kind of events. Best part is become part of groups. For example, if you are interested in Python programming, machine learning, find out the groups where they discuss about it, what they require. If you are interested in creating UIs, find out the groups which actually support these kind of things. They will provide you leads where you can provide support. So be very careful whenever you do contribution. So first is identify area to contribute. What you want to contribute to? Do you want to contribute code? Do you want to contribute to testing? Do you want to contribute to issue triaging? Then raise issue in the project's issue tracker. So let's say you want to make changes to how the wiki is there. You found that one of the steps in the wiki is old. The new version has a different step. You raise an issue and say that I have found this thing. I would like to make changes. This has to be changed. You wouldn't say, I would like to make changes. You would say this has to be changed. Then you wait for the acknowledgement for the project maintainers. If they feel that what you have raised is correct, they will say, go ahead. It will become an issue. Then once you get the go ahead, fork the project. So always keep in mind, whenever you're doing project, whenever you're doing contribution, create your fork first, make the changes in that fork. Don't create a branch, because contributions through branch may not be visible to everybody, but contributions through forks is visible to everybody. That is a thumb rule. Always keep that in mind. Make the required changes, build and test locally. That means use the whatever build tools that you have to use, whatever testing tools you have to use. Make sure that you are not introducing a new issue by fixing the old issue, because that happens with all the software engineers. Create a pull request with the issue ID. So whenever you're creating a pull request, always use the same issue ID. Don't forget to push that, whether it is a Jira number, whether it's a Bugzilla number, whether it is whatever it is, because that's how maintainers will map it to that your PR to that particular issue. Make changes as per review comments until maintainers accept the PR, then merge your PR. So this is how you can contribute. Now, where you can contribute, how to know what you can do. So we have something to help you out. Devang sir.
Yep.
The floor is yours.
So as you guys said, everyone is planning to contribute and be part of the open source space on any of the project. Now, majority projects are out there. As AP said, Firefox is there, and there is OpenShift, Kubernetes. There's a lot of projects out there. And there's one of our own project as well. And this is a passion project that, in fact, I have Ravi Dave, who's also part of the project that we're working as part of the session today. But AP, me and Ravi, we are trying to create something which is very unique and has never been tried I would say in the world. And obviously, we are calling all innovators. We would call every one of the contributors that we want as innovators. And this project is called Game Dora. And what we want to bring is the first ever studio as a service. Now, what does that mean? So ideally, a game would be built within a studio, and it would be built very close source. And we want to open source that entire process. And that is what we want to bring up as studio as a service. Now, we want to open source this entire concept. As AP said, that Game Dora is a concept contribution that we're looking at, or a concept community that we're forming. And we want innovators to be part of this concept, for us to start building and developing the new age studio as a service, the new age platform, the software, whatever you call it. So yeah, as we've put it, innovation is starting to explode in all the industry, and the gaming industry or the media and entertainment is not separate. So help us be part of this new age industry, be part of something very unique, innovate with us. And then obviously, if you want to put your name behind the innovation, be a contributor. Join these two links. These slides will be shared with you. But go ahead, go to community.gamedora.com or the github.com/gamedora link, and then start contributing. Start showing your interest, that you are interested. And you never know. Means starting few contributions would also earn you a swag, and would also mean that we would help you with your internships for this contribution. So once you start working with us, we will help mentor you on that as well, and then we can even help you get you a mentor certificate and things like that. So there's a lot of perks that we would want to give to you once you start contributing towards it. But the first step is for you to get that passion in you, to do something for the society, to take part, be a part of an open source, be a part of the open source industry. You can be part of GameDora, you can be part of any other, but get that fire in your belly, in terms of that you would want to give back to the society by doing something which is not something that you would want to profit from. So ideally, when you go to a company, you do internship, you look for stipend and things like that. But our suggestion would be that is something that you would do, but also give back to the society, give back to the world, something that you can do. And how can you do it? By contributing towards open source. Pick up a project, contribute towards it. If you want to be something, if you want to be a contributor who would like to do something unique, then go ahead, let us know and be part of GameDora. Anything you would want to add, Ravi or AP?
Yes, what I would like to say is that the best thing about contributing to means interning with open source is there won't be any limits to what you can do. You won't be put in a place where say, look, we already have done this, go and call it out. It should always be, okay, this is a new idea, this is a new way of doing it. Try it out, let's see how it works. So the idea behind open source is, again, it's an idea whose time has come. So circling back to where I started, in open source itself, an idea whose time had come. Open source thrives on ideas whose time have come. So go there, be a part of the community, work with them, try to provide support that you can. Because at the end of the day, even if I look at from a marketing, from a headhunter perspective, from a hiring perspective, people who have contributed to open source projects are far more, I would say, hireable than others, because their contributions are out in the open. There are multiple eyes have been there. Their PRs have been merged only after multiple reviews. They know how to use the issue trackers. They know how to work with SCM systems. They know how to use the build tools. So as a company, I wouldn't need to put my money again on those systems. I would know that you can hit the ground running. I would just have to give you minimal idea of how things work. Otherwise, you have the basic foundations. So that is the beauty of open source project, contributing to open source project. So go ahead, make your future yourself.
Yep.
Thank you.
Thank you, everyone. Any questions you guys would like to ask? Please feel free to ask.
I would say everyone should have one question: how should I start? Because that's what I had when I started in Linux 13, 14 years back. So anyone has that question, or they are just still thinking about what is open source and ये क्या पढ़ा दिया सर ने गीट और वो सब क्या क्या इतने सारी चीजें होती है वो सब हो गया.
How can one start? So, you want to take it, AP?
Sure. So main part is what is your area that you want? What is your interest area? Is it product development? Is it library? Is it game? Whatever it is. Once you understand that, look at the projects that's there in GitHub. GitHub is the best place at the moment. Find out what the particular project wants. Before even doing that, clone it, understand how it works, do all the things that has been said in the wikis, readmes, test it out. If you find some issues, raise a bug or issue and say that during testing we found this. So even without writing a single line of code, you have started contributing.
Yeah, I would say just go ahead, go to the Git or the community.gamedora page, go over it. You'll find a lot of things over there, and then you can find how to start over there as well. So again, as AP said, what is the area that you want to contribute in? You want to make something. Start by finding those and then getting moving ahead with those aspects. By the way, so if you don't have questions today, but you have questions later, let Abhishek or let the MITS SOE group know about it, and they can share those questions with us, and we can get back to you via any forum that you have. So don't feel obliged that you have to ask questions today itself. But future also, if you have any questions, let us know. We are pretty open to help you guys in terms of getting those answers.
And if you want to go in depth any of the topics that we discussed today, that is also possible. Means, let's say you want to know more about Git and how it impacts open source. It's up to you. Whenever you want, we can again meet.
Yeah. Okay, I guess that was. Go ahead, Akash.
Yeah. Thank you very much, sir. Somebody was saying something? All right. Am I audible?
Yes, you are. Yes, you are.
Yeah. So, thank you so much, sir. Actually, we had a lot of insight, different topics, and as in, of course, open source, but various aspects of open source. We were given insights about them. So we really have learned a lot, and hoping that all of us would be open source contributors in the future in some or the other way. So firstly, I'd like to thank AP sir and Devang sir, and for that matter, even Ravi sir. Thank you for joining in. Thank you for giving us your time, and thank you, for especially it was a weekend, so even the audience, all of you who joined, thank you so much for joining in. So we are also hoping to have more sessions, and like sir mentioned, you can ask any sorts of doubt. You can reach out to Abhishek, or you can reach out to me, and we can get you in touch with sir. If you need their contact number, I think they wouldn't have any problem. So we can also provide you with their contact number, and you can reach out to them. So we also have a small announcement. On the 8th of May, we have another webinar, and that will be on LinkedIn. So, which is next Saturday, I believe. So yes, Abhishek has put the link for the registration. You can, and even all the social media of Team ACES, the link is there. So what you can do is you can go us and follow us on Instagram. All the updates regarding events are put there. So yes, thank you so much for joining in. We also hope to connect once again very soon whenever we find an opportunity, and next time maybe we would ask you for something more from our side, and we try to be more interactive. So thank you so much everyone for joining in. We'll be signing out.
So everyone have a good weekend, and be sure to be safe as well.
Thank you for being great audience. Bye. Be safe.
Bye.
Yes, thank you.
Stay safe. Bye. Take care.